Here is the Galois question 2026, question 4. Okay, the set R contains the point 0, 0, 0, 1, 0, 4, 0, 9, 0, 16, and 0, 25. And we're looking for the midpoint of every pair of distinct points from R. It's plotted on the xy plane. And the question is, what is the number of distinct points that are plotted? First, we draw a graph to see what is going on here. So in the set R, we have 0, 0, 0, 1, 0, 4, 0, 9, 0, 16, 0, 25, and so on. Okay. So the midpoint, which means if it's 0, 0, and 0, 1, it's here 0 0.05, 0, 0, 0.5. And if it's 0, 0, and 0, 4, which means it's here 0, 2. And we also know the formula to find a midpoint for the two point is x1 plus x2 over 2, comma, y1 plus y2 over 2. So in the first question, we see that all the x value is a 0. So 0 plus 0 over 2 is nothing. It's still 0. So right now we only need to consider how many differences of y1 plus y2 here in this scenario. So we just list it out, which is, and also because there are six points, and based on the possibility, we know the maximum possibility here is 6 times 5 over 2, which is 15, which is not a lot. So we know the test, it is possible to list all of them out. Okay. So we write 0, 0, 0 plus 0, no, 0 plus, 0 plus 1, plus 4, plus 9, plus 16. So 1, 4, 9, 16, and then 25. And here is, so here I need to write clearly. So here is actually 0 plus 1, and plus 4, plus 9, plus 16, plus 25. Okay, continue. Here 1 plus 4, plus 9, plus 16, and then plus 25. Next is 4 plus 9 plus 16 plus 25. 9 plus 16 plus 25. Lastly, we get 16 plus 25. So we get 1, 4, 9, 16, 25, 5, 10, 17, 26, 13, 20, 29, 25, 34, and then 41. 1, there's no repeat. 4, there's no repeat. 9, there's none. 16, nope. 25, there's 1. So this one go. 5, no. 10, no. 17, no. 26, no. 13, no. 20, no. 29, no. Here 25 with only 1 because we crossed out the first one. And then 34, 41. Okay, we just count the number left here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the first question, the answer here is 14. The reason why we can do the list, just do the listing, because based on logic, we know the first question is always, in the Galois, is always given us to find some like the pattern. And second, because based on our calculation possibility here, we know there are only 15 possibility, which is possible for us to list. Yeah. So if we see a similar question, but after we try to see how many possibilities here are here and see a really big number, we know maybe we're doing wrong if we're just trying to list all of the possibility. And there also might be some hidden hint we didn't see. Okay, we continue. Next question. The set S contains exactly 20 distinct points. Each of the from the n plus 2, where n is integer and 1 and n is bigger or equal to 1 but smaller or equal to 20. And the midpoint of every pair of distinct points from S is plotted on the xy plane, determining the number of distinct points that are plotted. Okay. So we still need using this formula here. Okay. We're looking for the midpoint such that n1 plus n2 over 2, comma, n1 plus 2 plus n2 plus 2. Here is n, here is 2 over 2. It's a midpoint. So we simplify this. We get n1 plus n2 over 2 plus 2. And this is our y value, and this is our x value. Okay. So since based on the question, we know x is an integer and it's between 1 and 20. So we know the smallest value of n1 plus n2 is 1 plus 2, which is 3. And the biggest is 19 plus 20. Since here, as long as we get a x value, that is, no matter what, for example, even we get 1 plus 7 or 2 plus 6, even though n1 and n2 are different, we still get the same y, since here this part is maintained the same for these two scenarios. So the result should also be the same. So which means each x value is only has one y value. Okay. Based on this, we see 20 equals 39. Okay. 39 minus 3 and then plus 1. We get our desired answer, which is 37 possibility here. A set T contains exactly 100 points having distinct y coordinate. The midpoint of every pair of distinct points from T is plotted on the xy plane. Determine M, the minimum number of distinct points that could be plotted. And the complete solution include value of M, a set of points T that satisfy the requirement, and then reasoning. So, first of all, based on this, write down the general formula for midpoint. So xa plus xb over 2 ya plus yb over 2. And the restriction for x is none, and then for y is yn should different from yn plus 1. Okay. So based on this, we could see if you want to try to minimum number of distinct points that could be plotted, we need to let this equation satisfy xa plus xb equal to xc plus xd. Meanwhile, also satisfy ya plus yb equal to yc plus yd. This means we need to manipulate both x and y at the same time, which is hard for us at the beginning to see a pattern. So since there are no restriction for x, and we also see in the question 1, where when the x equals 0, it's really easy for us to manipulate the y value and find the midpoint of it. So we propose that what's going to happen if you let x just be 0, and then we only focus on y. Is it possible? Yes, it is possible. So the general formula becomes 0 ya plus yb over 2. Right now, we see the summation ya plus yb determine the number of points that could be overlapped. So if we just need to maximize the point, I should say maximize the value of points that are overlapped, then we could get the minimum number of distinct points that could be plotted. So to maximize the number of points that could be overlapped, we need to let y to be equally spaced, concentrated, and continuous. Why equal spaces? Because we want when I plus j equals something, for example a, when I shift leftward 1 and j shift rightward 1, when they have still plus together, they still have the same value. Yeah. And concentrated and continuous is really easy to understand. Okay. So based on this, we know actually what we're looking for is an arithmetic series. So where yn is equal to yn minus 1 plus d. Since we see something like this, well, it is really easy for us to find m by substitute some number for d and y. Here d can substitute can be any number as long as the every d between two numbers is the same. But because here I want the easier calculations, so I substitute d equal 1 and let y also be y1 also be 1. So as a result, y2 should equal to 2, y3 equals 3, so on, to get our final number y100 equal 100. So based on formula, ya plus yb over 2, we know the smallest summation of ya plus yb is 3. And the max is 100 plus 99, which is 199. Since here, all the number we listed here is in the exist in Z, and two integer number are together still an integer number. So this means the m for the value of m is 199 minus 3, and plus 1 to include y plus yb equals 3, which is get 197. And this is our value of m. And this is also the smallest since as long as we have 100 distinct y value, and if we want to looking for the midpoint of it, we at least will find 197 possibility for the two y value, sum of two y value. Yeah. And here's the solution. But we find the solution, which is 197, and I also provide a set of t, which is when yn equal yn minus 1 plus 1, where y is between 100 and 1 in Z. And then we also see the reason because y1, ya plus yb, the possibility of this, the minimum is 197. But the interesting part of this question is not yet finished. If we draw a graph and we plotted all the midpoints we find for yx equals 0, and we connected them, we see it's forming a straight line where the slope is undefined. And we see that if we change the slope of this line, the value of m, the minimum point of this point I could plot it, doesn't change. Since it will just be based on the equation of the line y equal mx, here m is not the slope, plus b, we could write x1 plus x2, or xa plus xb over 2, comma, here the slope times xa plus xb, and then plus the b for constant over 2. Here, we see a similar thing as what we do for reducing x to 0. By doing this, we reduce one variable, and if you treated xa and xb same as ya and yb, we definitely will find the same answer for m. Meanwhile, we can see in the graph, if say what I draw right now is midpoint, we can see there's always a midpoint corresponding to one midpoint on the straight line where the slope is undefined, corresponding. See? There's always 2 points corresponding to each other. So we can conclude that as long as there's a linear relationship, and when the slope is not equal to 0, at the same time, the value we input is equally spaced and continuous. We always will find m as a minimum number of distinct points that could be plotted, which is 197 in this case for 100 distinct y coordinates. Okay, that's it. Thank you for listening and have a good day.